So now, until now, what we have is that we have just discussed. We started our course with something called with a database called as MySQL. Okay, so we had a quick introduction to that. We had few sessions on the MySQL. So this is something which we discussed. Okay, and MySQL, we understood that MySQL is an RDBMS. Okay, and then it is used for saving the data which is coming from anywhere. Okay, if you want to save something, so we had a very detailed sessions, all these things where we understood what is a database and what is, I mean, why we need a database. So if we have an understanding of database, so the entire purpose of the database is to save the data, right? So that is what we want. The data can be coming from any sources. It can be coming from a real-time source. It can be coming from a, I mean, from a website. It can be coming from an application. The data is very huge and it could be coming from a multiple place. We also have seen in one of the session is that we also generate a lot of data on a daily basis. The session we are having right now, it is also generating a lot of data. It has a data in terms of I'm speaking something, we are speaking something, that is a data, and then I'm sharing my screen, that is a data, how many people joined the session, that is the data, what is the experiences of each and every person. So we have a lot of data generating every day. Our phone generate data, our smartwatches generate data, our Google searches generate data. So data is everywhere. Okay? So if you want to understand the data, so first of all, you have to save the data somewhere, right? So when we go to the traditional ways, so how the data was stored, it was stored in the relational database management systems, and these were on-premise databases. What we understand by the on-premise is that we have to download it, we have to manage it, we have to maintain it, and we are responsible all for all the things. For example, if we look at the example of MySQL, we installed a MySQL on our system. We had a couple of hiccups as well, right? So we had issues. So when we were installing MySQL, it was giving very weird errors. Then we had to uninstall it. Then we had to reinstall it. And again, we saw a new error. And then it was a very nice thing. We learned a very new type of errors which we faced. So we didn't had someone like who can manage it, who can maintain it, who can install it for us, who can say that, okay, dear, everything is done for you. MySQL is installed and you are ready to use it. We didn't have something like that. So we were solely responsible for everything. And now I have MySQL installed on my system. So if I show you, then if, for example, right now it is MySQL Workbench 8.0. If I want to upgrade, for example, 1 year later or 6 months later, Microsoft Workbench 8.1 comes, then it is my responsibility to upgrade it. And then, for example, if during upgrades I find if I face some issues, I have to look into it, or I have to do Google for that, right? I have to do everything, right? So it is my responsibility. So this is what was the concept previously, that we had something or it's on premise. So on premise is that everything is on my premises and I have to take care of this. I am responsible for it. And one more example we can have for on premise is like you buy your own car. So when you buy a car, it is your responsibility. You have to take care of it. And then it is your responsibility. If you want to upgrade your car, for example, if you want to change your tire rims, for example, then you have to take it to the showroom and get it upgraded, and then you will have to pay for that. Right? So these kind of things we have seen that everything used to be our responsibility, but it can become a big challenge as your systems grow. For example, if you have a car, it is very easy to manage and maintain it. You can wake up at 6 a.m., clean your car, nicely perfume your car, and then you use your car for the entire day. And then, for example, now you have two cars, then it becomes okay. It becomes challenging. You can wake up still at 6 a.m. and but you will still be worried that okay, I have to clean two cars. I have to take care of everything. If there is any problem in the car, I have to fix it. For example, one car is having a flat tire, you will fix it. And if there is any damage to a car, you will have to take the car to the service center and get it. Now let's imagine if you have 10 cars. So now you can see that it is a very big headache for you, right? Then you can see how difficult it becomes as these different things if you have if they increase. If you have one phone, that's fine. It is easy. If you have 10 phones, what if I give you 10 phones? How will you manage everything? It will become very difficult because these days the phones batteries are also very bad. They get down very easily. So how will you make sure that all the phones are charged all the time? They have proper internet pack, and if the internet pack is not expiring, so here you can see that, right? This was also the problem which came up to the IT industries as well. When the systems were small, the managing, maintenance, everything was very easy. But once they grow up to, for example, 100 instances of MySQL or even 10 instances of MySQL, then it becomes very, very difficult to manage each and every system, right? So that is why one very fine day, AWS came and they said that, why don't you give us all these things? Why don't you give all this headache to us? We will take care of all the systems. We will have our own infrastructure. We will have our own hard disks. We will have our own RAM and CPUs, and we will install everything on our system. And we will take care of everything. We will install it. We will download it. We will do everything for you. And if there is any problem, I will take care of that. Right. So that is where the company found that it is very easy when you have someone who is taking care of the things for you. Right. So that is where we had something called as different cloud technologies. So the cloud technologies came up with the promise of having a place where everything is already managed and maintained for us, and we just have to use the service. One example, we can have different services. We already are using these kind of systems without even knowing. For example, if I say Google Drive, right? We all use Google Drive without even asking any questions. So where that Google Drive is saving that data, how that data is being retrieved, in which language Google Drive is written. It is in HTML, it is in FHTML, it is in Ruby, or is it in Python? We do not even know in which language it is written, where it is existing. The drives, with the different files which I place in Google Drive, whether they are in USA, whether they are in Japan, whether they are in Australia, or if they are in Africa, we do not even know. So we are, as a user or as a consumers, we are concerned that as long as our needs are met, we do not care about what is going on in the underlying, as far as I am able to use my services uninterrupted way and without getting into the technical nitty-gritty. Okay. So this was the different cloud technology. On the similar pattern, we had more and more softwares which were coming up in the market, which promised us a very good future because we didn't have to get into really, really small issues all the time. One of the software which is available to us is called as Snowflake Data Warehouse. Okay, you heard it right. Maybe someone may not know it is a software. So Snowflake Data Warehouse is a software as a service. So Snowflake Data Warehouse is a software as a service offering that is available to us. It is nothing. It is again an RDBMS. I mean, it has a lot of features, but simply speaking, right now, just to keep things simple, you can consider it to be a database which is managed and maintained by someone else. Okay. So over here, so that is why if we compare it to MySQL, we do not have to install my Snowflake data warehouse. We do not have to manage anything. Everything is already done for us, and we are just ready to use it. Right? If you have been already using the Snowflake data warehouse, you know how easy to use it, and we just need a browser to access the Snowflake data warehouse. Just like your Google Drive, just like your Netflix. So we have Netflix as well. So we also use Netflix to watch movies without even knowing how those movies are stored, where they are stored, where the recommendation engine is running, how all these things are happening at the backend. Just like that, the Snowflake data warehouse is also maintained, managed, and all the upgrades, and everything is also done by the Snowflake data warehouse. And we just need only one thing, which is called as a browser. We just need a browser and nothing else to access our system. So that is the simplicity, which is also with the Snowflake data warehouse, right? So it is very easy to use. It is very easy to access. And now we can start using the Snowflake Data Warehouse just like any normal relational database management system. We can do a lot of things on top of that, but simply doing a comparison with the on-premise databases and data. Okay. So now let's consider one more thing. The relational database management systems which we had, for example, MySQL. Over here, we saw that we can create something called as schemas. And inside of the schemas, we saw that we can create some tables, right? So the tables is something which store the data for us. But one thing we have to consider that these RDBMSs or these databases which we have, they were very good with storing the data, retrieving the data, and inserting the data. Okay. So for example, the inserts, it is optimized for some things. Okay, I mean, here you can see that it is optimized for storing the data, right? For inserting the data, for updating the data, right? So it is very good at doing those things, right? But over here, for example, if I have a MySQL system and MySQL is very good with inserts and updates, and on the same system, I also want to do some reporting, for example. I have a very complex queries. I want to run them on the system, but that could be very challenging because the system over here, the RDBMS, is not optimized, although it can do it. We have seen that we can run a lot of select queries, a lot of complex queries, but the thing is that it is not optimized for these things. As you can see, because MySQL was developed I mean, it is very old databases. So in the times that because the needs are changing, we need not a database not just to store the data, but also to retrieve the data optimally. We also need to retrieve the data faster. So that is why where the different on-premise systems or the different legacy databases are missing, that they are not optimized for the aggregation. They are not optimized for the different operation which we want to do as a part of our analysis. They can do it, but they are not optimized for that. Okay. Relatively, they will take more time for that. So that is why what we want to do is that whatever data we have in our databases, we want to first of all move that data from the MySQL instances into the Snowflake data. You might have seen a lot of clients are doing this through different ways, which we are going to talk about. But this is the pipeline which is going to be very predominant in the IT market since for the last since 5 years. You can see that this is a shift which is coming up in the IT market, and it is very prevalent and predominant. Okay. This is not like just one company is doing, two companies doing, but a lot of people are doing it, a lot of companies are doing it, and they are also finding the benefits of that. Okay. So now these data warehouses, right? So for example, if you talk about the Snowflake data warehouses, it comes with a lot of benefits because of which there is a shift coming from the MySQL to Snowflake data warehouse of or why we even need to integrate these two systems, right? So over here we can see that we have stored a lot of data, and then these databases already have a lot of stress on themselves. They are inserting the data, they are updating the data, they are deleting the data. So there is a lot of things going on in the database. It is fine if you have very small system, you have 10 tables, you have 15 tables, and those tables have like 1,000 records. That's fine. Then you can do all the things, your data inserts, update, delete, your select queries, your analysis is all okay. You can do all these things in one place. But again, as your system grows, as your demands grows, and as the data grows, it becomes very difficult to manage all the things in one system. It becomes very difficult to insert the data in one system, update the data, delete the data, then running your analytical queries on one system. Your system will not be simply able to handle all the different type of additional headaches which you can have. It will say that, oh, wait. You want me to insert the data. You want me to insert like a million records every day. You want me to update the data. You want me to also run analytical queries on those million records. I cannot handle that. It simply cannot handle that. And again, the problem with the on-premise systems that these are not very easily scalable. For example, if I have MySQL installed on my system, um, it is not going to be a 5 minute task to increase the RAM or even 10 minutes to increase my hard disk. I am limited with some hardware requirements. I'm limited by the resources. then it becomes very difficult for me to scale up. If I want MySQL to have more memory, I will have to increase the memory of my RAM of my system. I will have to increase the RAM from my system. If I want MySQL to have more hard disk, then I will have to get my system upgraded. So here you can get the idea of how difficult it is to scale up and to manage everything. So it's so you can see that, right? So for example, if someone tells me I want MySQL, I want to use MySQL for example, big data. I don't think it can actually handle that. And one more problem with the MySQL is that, okay, I'm not saying that MySQL is very bad. It has its own advantages, but we are just now focusing on disadvantages. One more disadvantage is you can see that it is, I mean, it cannot handle big data. It cannot handle semi-structured data. It cannot handle unstructured data, right? So now, as the time is growing, our needs are also changing with the time. So that is why these systems which we were using for last 15 years, 20 years, they are not able to do all those things which we want right now, right? So it happens every time. 10 years back, I mean, 15 years back, we had simple phones. Our needs were just to call someone, send a quick message, or to set an alarm, to have a very small calculator. We were fine with small phones because our needs were very small. At that time, we didn't use Google all the time. We didn't had any exposure to WhatsApp. We didn't even know that those things even exist. So that is why MySQL was having its golden age, and it was providing all the great things which people required to store the data, to manage the data, and to do minimal analytics on top of that. But now, fast forward to 2024, although I mean the shift has started happening a lot of years ago. But let's talk about today. We have a lot of data which is generated. The data is generated in multiple sources. It is generated in multiple types of sources. I mean, it can be generated from a phone, it can be generated from Google, from LinkedIn, from you can imagine your smartwatches. So the data is now being generated from multiple systems, which was not the case previously. And again, on top of that, the data which is generated is becoming very, very huge. You can see that your smartphone produces a lot of data. And the problem, right? I'm not the problem. The good thing is that if you look at the smartphone can be used by even a 5 years old, 5-year-old child. That child is also generating some data intentionally or unintentionally. Okay, this thing we also want to recognize. We do not always intentionally generate the data. We also unintentionally generate the data. For example, if you are using a smartphone, for example, and you open a specific app every day, you talk to people on WhatsApp, you talk to people on, for example, Telegram, or you watch reels on Instagram. Okay? You are not generating any type of, you are not intentionally generating what type of reels you like, what type of data you like, which app you use for more time. But all those data is being generated internally by your smartphone to enhance your experiences. Your smartphone will see that most of the time he is watching reels. What type of reels he like? How much time he spends on watching Instagram? How much time he spends on talking on WhatsApp? So all those things are being generated at the back end, and it is for your good experience, right? So all these things were not possible by handling in the MySQL, because as we have seen, as the data increased, as the source system increased, and again the different formats in which the data is generated. Right now we have data generated in CSV files, in Parquet files, in JSON files. We have a lot of different files in which the data is included. And all these different changes which came on, these changes didn't come on abruptly, but these came very, very slowly, but very, very confidently. So now we have different source systems, we have different file formats, we have very, very large data generated on each and every system on a daily basis. Okay. So the MySQL was not able to do everything. It is good. It was good. It was optimized for inserting the data and updating the data, which is structured data. Okay. So that is why there is a shift coming on from the on-premise system to cloud data warehouses. Okay. So why did cloud data warehouse? Because of the scale. Things are moving very fast. a lot of data is increasing every day. I cannot create a data warehouse system and store all the data in one place, because tomorrow I might need double the capacity. I mean, I might need double the storage. I might have to triple the storage maybe 6 months from now. So how do I handle all those challenges? Who is going to take care of? Because if I am the owner of a company, I do not want to take care of all these things. I want someone to manage everything for me at a lower price, right? If I even hire a team to do that, then that team is going to go through a lot of skill sets. I will have to hire them. I will have to give them salary. So all these things, that is an additional headache. Okay? So that is why there is a shift coming from the on-premise data warehouses, databases, to these cloud data warehouses. The good thing about these cloud data warehouses is that they are scalable. Okay? So if today you need 10 GB of data, you can have it. If tomorrow you need 15 GB of data, you can have it. And then if and scalable in terms of hardware, I mean, you can talk about in scalable in terms of storage. You can ask for any storage. You can not just increases, you can also decreases for it. Decrease it. For example, if you had 1 TB yesterday and today you need 500 GB, you can do that, which was not so easy as we had seen in the previous databases, right? You can be, and it is very scalable in storage. In memory, for example, if you need more RAM, less RAM, you can also do that. In the processing as well, right? So if you look at the processing, if you need one 10 core CPU today, that's fine. If tomorrow you need 20 core CPU, that's also fine. That is very easily scalable. Everything is very easily scalable, and you can scale up, scale down, scale out, scale in. So we'll talk about this. So all these things are very easy in these self-managed data warehouses. Okay. And now another question which we have right now. There are a lot of cloud data warehouse solutions available out there in the market, right? We have Redshift. Redshift is there. We have again the Snowflake Data Warehouse is one of them. Snowflake Data Warehouse is there, and then you could argue we also have the Databricks as well. Right? Databricks is also there out there in the market. Yeah. Then why are we even talking about Snowflake Data Warehouse? What is so special about Snowflake Data? The Snowflake Data Warehouse is, first of all, it is very easy to learn. The next thing is that if you might have had any exposure to Redshift and Databricks, you have to first of all create clusters, manage your clusters, define what you want, and you have to define everything from scratch, right? I have worked in Databricks, I have worked in Redshift, and I know how painful it is to first of all create clusters, and you should understand the technical details. For example, in the Databricks, you have to decide, okay, what type of node you want, how much compute nodes you want, how much worker node you want. So you need to understand all the things. Yeah, as a person who is starting out his journey in the data warehouse terminology or in this world, they do usually do not know these terms. When they start out, they do not know what is the cluster, what is the worker node, what is like what all is going on there, how what is an executor, for example, right? So this is where the Snowflake Data Warehouse shines really bright. You do not have to know any terminology about the Snowflake Data Warehouse or the cloud data warehouses. You need not know what is a cluster. You need not know what is a node, what is a worker node, what is an executor. You simply, I mean, you do not have to worry about anything, and you simply get started like any software which you okay, because you are focusing less on the unwanted details. You can focus on your work, right? So whereas in the Databricks you have to create your cluster, you have to see how to create clusters and all these things, and then finally if you are still not able to run anything, you will have to go back, increase your clusters, increase the size of cluster, adding one more worker node. So it is a very challenging thing sometimes. So if you're a beginner, and if you even if you're a pro, right? We are not saying that Snowflake Data Warehouse is good only for the beginners. It can handle a very good amount of. I mean, it is very good at handling very good amount of workload. And again, in the Snowflake Data Warehouse, we will see that how we can. I mean, we can work very easily. We have a very intuitive UI. and it can be, I mean, it is very, very nice. Okay, we will see that. Okay. And another thing with the Snowflake Data Warehouse is that Snowflake Data Warehouse is you have a very good trial period. You use it for 30 days. And over here, we have a very, very good set of features which are not there in the Redshift Analytics. Okay. So as this is a cloud data warehouse, we will see that this we will not be managing and maintaining. Everything will be done for us. Okay. We just have to create an instance of the Snowflake data warehouse. We have to go to their website, register ourselves, and that's it. We can get started. That and it is ready to use. We do not even have to create a user. We do not have to create any cluster. We do not have to do anything. As soon as your instance is created, you can start. You can connect to through the browser to your Snowflake data warehouse, and you're good to go. You can start working with that very, very easy. Nothing else required. Nothing required. Yeah. And again, another thing which was missing on the on-premise systems, it is managed, right? So everything is managed, everything is maintained, and if something goes wrong, if something there is a issue with the Snowflake data warehouse, then you can also raise a ticket, and the Snowflake data warehouse team will help you to take care of your instance, and you do not have to get into all this shit. Okay? And again, the modern data warehouses which we have over here, apart from being scalable, they are also very, very optimized for the analytics because this is what we want. We can store all the data in these databases, right? These are good for storing the data, for inserting huge amount of data, for updating huge amount of data, for deleting a huge amount of data. But now this is not just we want. We also want to manipulate the data. We want to run analytics against our data. We are data engineers. Data engineers do not just store the data in one place and sit like this. Right? We have to understand the data. We have to understand the pattern which is there in the data. So that is why, because we haven't just already understood that these databases were not good, were not, I mean, they were not created with an intention of analytics in their mind. They were created with an intention to store the data optimally. Whereas the modern data warehouses are created with an intention of creating great systems who can handle and do analytics at a very, very high scale. Okay, so you will see that there is something called as MPP. So there is multiple parallel processing. Okay, there is also different terms to MPP. So you can say that these systems, these modern data warehouses, which we are mentioning, the modern data warehouses are created with a mindset set of creating systems which are optimal for data analysis. Okay, analysis. Okay, so this is what we want. We want to understand the data. We want to analyze the data, and these systems are optimized for these things. Whereas the systems which were created previously, they had different intentions. But now these systems are now created with an intentions of what we want today. Not we wanted 10 years back, not what we wanted 5 years back, but these systems are created keeping in mind the growth at which the data is increasing. So the mindset over here is that we can handle huge amount of data, right? And then the other mindset is that we can analyze different sets of data, different types of data, different types of data. For example, if the data is coming in the terms of CSV file, it is coming in JSON file, Parquet file, Avro file, we should be able to analyze all these different types of data. Could be structured, could be unstructured, could be semi-structured. So we should be able to handle all these data. And all these data can be coming at a very, oh sorry, not handle, but handle. We should be able to handle these huge amount of data as well, right? So these systems were created for these things. And finally, which we have already seen, that so that we can not just store, but we can analyze the data at quick speed. Okay, so these are the mindset of the system. And again, which we have already discussed, I also wanted to mention over here, we do not want to get into the complexities of managing. managing and maintaining the systems. Okay, this is also very, very important. Okay, so these are the main things. These are the nice things. And then one more thing, I just want to mention it as 3.1. The systems are easy to use. Okay, easy to use. I mean, if someone gives me two options and everything is managed for me, but still there is a level of difficulty of use associated with it. So of course, I will go with something which is easy to use, right? Why not go with a system which is easy to use, and why to go with a system which is even it is free, even it can do the same things, but it is very, very difficult to understand, right? Okay, so over here you can see that these are the points or these are the main things why everyone wanted to move to the Snowflake data warehouse. There are multiple tools, there are multiple systems out there in the market, but due to these things, we are moving to Snowflake. Okay. Okay. So now the companies were convinced, okay, everyone was convinced that okay, these systems are good for storing huge amount of data, and these systems are very good to analyze the data. Okay, so now we want, so the next step is that we have understood the advantages of moving to Snowflake Data Warehouse. And so how do I do this? How do I move my data? Okay, so over here, we had different ways or different companies came up with their own migration techniques. So we had to migrate the data, right? So over here, for example, the MySQL was a legacy system and it had 10 years of data, right? So all the 10 years of data, for example, if this is, for example, 10 years of Flipkart, it has last 10 years, how many customers have visited my website, how many times the customer has visited my website, who has bought what is the recommendation, what products they really like, what products they do not like, on what products they have given their feedback, how much star ratings they have provided, how many times they have logged into their system. All these data for the last 10 years is sitting in this database. Okay? But then I want to analyze the data in this system, right? Do you really think I need to understand the data of last 10 years? Is it really relevant? Because the choices of the people are also changing very, very frequently. What we want today is not what we wanted 5 years back, right? You can really think of it in terms of anything, right? Anything which is happening around us. So it could be your smartphone, it could be the internet, right? We were really happy with small sizes of internet and very small internet packs, and I mean we were really happy at that time. We used to say, okay, what will I do with the internet? We didn't actually realize the power of internet, so that is why we were really happy with that. Okay, that's fine, I do not need to run all this thing. We had no music apps, we had no music, we had no YouTube. We were happy with the radio as well if you go back in the time. Okay, but now, as the time grew, our choices changed. Then we had, for example, first of all, we had music players. Then we had iPods. So iPod revolutionized everything. Then we know, oh, this is also possible. Then our thinking and our choices changed with the time. Then we have recorded systems. We had tapes. We have CDs. Then we have different systems, and now finally everything is in our smartphone. So this is how you can see that the people needs and the sentiments of people keep on changing with the time. Okay. So similarly, understanding the last 10 years of data, analyzing the 10 years of old data will not make sense today. Okay, so that is why we need to understand, for example, 1 year of data, 2 years of data, or 3 years of data, not older than that. I do not want to understand the data which is, for example, older than 3 years. Okay. So over here, one strategy which I have understood is that when I am going from this system to this system, I do not need to move all the data or the entire historical data from my this system into this system. For example, the very first strategy which I have understood is that, for example, I am fine if I move 2 years of data. That is fine. Okay, this is fixed. I do not want to take 10 years of data to my Snowflake data warehouse because analyzing what happened 10 years back will not make any sense. Right? This is fixed. Okay. And the next thing which I want to know over here, what strategy should I go with? How do I even migrate from my on-premise to the cloud data warehouse? Right. So there were multiple ways. So let's look at the multiple ways which we decided. So the very, very, very used and the very popular way to move to our from any on-premise system to our Snowflake data warehouse is by using S3 buckets. Yeah. So what the customer did is that we had a storage. This is a service by AWS, which we will deep dive. Okay. So in the AWS, it is just like a Google Drive. You can place any data. You can, I mean, you have a plenty of storage. And then on top of that, it is very, very cheap. Okay. So what customers did is that, okay, let us create a strategy where I will extract the data tables data into files, and I will keep putting those files into the S3 bucket, and then I will consume those files from S3 bucket into the socket. I cannot tell you how popular this way is and how many companies are actually doing it. So if your company is doing it, can someone tell me whose all companies are doing this way to migrate to Snowflake Data Warehouse?
Yeah, what is the question? Can you please repeat?
Okay, so you might have seen that this was the very, very basic way to move to from your on-premise system to Snowflake Data, right? So I just want to know if your company is also using this, if you can agree that, okay, this my company is still doing it, and this is something which I have already, I mean, seen these days happening.
Yeah, they are using some migration tools, right?
Right. So this is very one popular way using which the companies are migrating to Snowflake data warehouse. They have some tables data. From those tables, they select only specific period of data and they extract the data into the files, and then they consume those files into Snowflake data, right? This is one way. Apart from that, if companies have for example, if a company have wanted to do in a more better way, they do not want to expose their data into the files. For example, it is a banking organization. As a banking organization, I do not want to put everything into the files out there in the cloud before getting into the Snowflake data. So I do not want my data to be on the cloud. I Let's say, for example, while the data is being copied from here to here, what if someone takes looks at my data or understand my data? I do not want
Encryption.
to get into all this, right?
Encryption.
Yeah, sorry.
Yeah, they use encryption, right?
Right. You can use encryption, yeah, of course, but it is an additional headache, right? So for that we have to do that. So now some companies you started using something called as ETL tools. Okay? So I have mentioned E, T, and L. So what they did, they started spending some time. They started, for example, you can say that they started investing into the ETL tools, which provided more features. For example, if I wanted to, for example, migrate a table, I create an extract for the table into S3 bucket, and then I consume that S3 bucket into the Snowflake data. Over here, I am not able to do any transformation to the data. I'm just simply moving the data from one place to another place, and I cannot do any transformation. For example, if I wanted to clean some data, if I wanted to transform the data, I was not able to do it using this way. So that is why companies came up with another way of moving from the legacy system. For example, they extracted the data from here, they did the transformation, and they finally used to transload the data from here to here. So this was another very nice way which helped companies to migrate from MySQL from any on-premise databases to data. Who, I mean, can you tell me who is using this way to migrate to Snowflake Data Warehouse? I just want to know which is the predominant way the market is doing right now.
There are many tools like Informatica
So
and
majorly your company is doing this way or this way? The option one or option two?
option one.
This is the option one. This is option two. So everyone, I just want to so whosoever is working on Snowflake data warehouses, I just want to know whether your organization is going through the option one or option.
We are using the Spark, right, to load the data.
Sorry.
We are using Spark.
Okay, you're using Spark to migrate.
Yep.
Okay, neither option one nor option two.
No.
Both options are not
We,
available.
we have
Okay.
built a tool, right?
Mm-hmm.
Which is having the endpoints, right? So source will
Okay.
be any database and
Mm-hmm.
target will be Snowflake.
Oh, that's great. That's great. Okay. So
And
we
we
will
are not
mention
doing any copy command and all that, no file and all that.
directly it is going into
Directly
the system.
connecting to the database.
Okay, that's great. So in this case, let's look at the option number 3 for that. So the third option which we have, so let us first of all look at the disadvantage of using the ETL tool. Again, the company has to pay more money. They will have to set up the installation. They need people who know ETLs, and then ETLs, I mean, it requires a different skill set, right, to migrate to a system, right? Then the companies came up with something called as ELT terminal. This is ETL, where we first of all extract, then we transform, and then we finally load it into the target system, right? Whereas we also have something called as ELT. So whereas, so over here, you can see that extract. This is E. This is first of all you load it, and then we also had some different softwares. Using it, we can transform the data into the Snowflake Data Warehouse itself, right? So we do extract, we do load, and then we can do the transform later on. So over here, we also had this option over here. So we took some data into the Snowflake Data Warehouse and we used to write it back up. So over here, we had something called as the transformation was a later step, right? So over here, as a part of ELT, we had different tools like we had DBT. So DBT is a very nice and very popular choice out there in the market, which will help you to transform the data which is already loaded into the Snowflake data warehouse. Okay. So broadly, we have ETL, which we have already seen, in which the data is first of all extracted from the source system. It is transformed into the ETL tool, and then finally it is loaded into the target system. Whereas the second option or the above option which we discussed, first of all, we extract the data, we directly load it into the target system, and then we do the transform on top of that system once it has been loaded. Okay, this is one another way of it. So this we will also understand. We also have a detailed course on the DBT where we will see how the DBT really nicely integrates with the Snowflake data warehouse and helps us to do the transform. One more thing, why this ELT is sometimes preferred. Of course, this is a nice way to transform the data later on. Of course, we can first of all bring the data, every data in one system and then do the transform. And again, because we have a lot of space, lot of memory, a lot of resources at our disposal, we can go with transformation later on. So these are very. And on top of that, we can also have different system. We can build programs, right? We can build different pipelines. The programs can be pipeline as well. So in the pipelines, what we will do, we will connect to a source system. Of course, everything is going to be the same, right? Either we follow the ETL or we do ELT, and we can do this using multiple systems. For example, we can build a pipeline. For example, we extract using Python. We transform using some, or for example, even Python as well. We transform the data and then we can load it using Python as well. Or we can also have different ways. For example, we extract it in the S3 buckets, right? So extraction is in terms of file, or though, so it could be any SQL query, okay? Anything which is scheduled SQL command using which we are extracting the data from here to here. Then we transform it, for example, transform it using Spot, for example, right? We can do transformation on these S3 files, right? And then we can load it again using Spot, right? Is this the pipeline which we have?
Yes, I am here.
Yes, this is the one, right? Or do you have something else? So you do extraction using Spark as well, or you first of all extracting in the S3 buckets and then do everything using Spark. Of course, you'd have to move it to your HDFS, right?
No, we use like
Mm-hmm.
AWS migration service.
Okay. So you put it in the S3 buckets,
Yes. So
right?
migration
So
service from
right,
there.
right. So you extract it in the S3 buckets and then you do the transformation using Spark and then you load the data using Spark as
Yeah, actually, this is
well.
not like a warehouse database. This is like
Mm-hmm.
DBMS only.
Okay.
So there was no like transformations. The
Mm-hmm.
same just extract load. That's it.
Okay, but we can do just in case if you want to do the transformation, you can take the data and then you can create a data frame for that, and then you can play around with that. If required, you can also do the transformation, right? So there is a capability, right?
Yes. Yes.
Okay. And similarly, we can also do some other stack. For example, you can have the extract in S3 bucket, and then transformation you can do, for example, any database, you can do transformation, or we can also do the same thing. So ELT, which we discussed, we extract in the S3 bucket, we load it in the Snowflake data warehouse, and on the Snowflake data warehouse, we can do the transformation. For example, this transformation later on using dbt. You can extract the file in S3 bucket. You can load it in Snowflake Data Warehouse, and then you can do the transformation using Snowpark as well. So the options are in unlimited. Okay, so one more pipeline which I want to mention over here. You do the extraction in S3, then you do the transformation using, for example, you can transform using Databricks, right? You can do the transformation using AWS Glue as well, right? So as a data engineer, we will understand all these things. So for the transformation, there is Databricks. You can also load the data again using Databricks. So in the Databricks, you can also load the data, and you can also load the data. You can do all these things over here. Whereas our target, so I'll mention one more column over here, the target system. In this case, we are interested in migrating the data to the Snowflake data. I'll mention SDW, SDW, SDW. Okay. So as you can see here, there are a lot of ways to migrate the data from any system to the Snowflake data warehouse. You can go with any of these options. Okay. So here you can see that how many systems or how much many options, it is so very flexible for us to move from one system to another system. You can see that these are just few of the options available. We have not even talked about different ETL tools. We can also use ETL tool. For example, I'll mention a few ETL tools, few popular ETL tools. We have SAP Data Services, we have Informatica, right? So for these tools, everything is already sorted. Okay, so we have Informatica, and someone mentioned, oh sorry, Informatica. We can use, I mean, someone mentioned, right? So someone mentioned Matillion. So Matillion is also an ETL tool. So over there, everything is done for that. So can someone tell me any other ETL tool someone is working on right now apart from
Data
these?
stage.
Yeah, data stage is also there, very popular. And anyone, anything else?
ADF, Vipul.
Sorry,
Data
EDF.
Factory.
sorry. I am hearing two, so I'm sorry. Can you repeat?
Data Factory.
Data
Data
factory. Yeah, ADF is also there. Very nice. So we can also use ADF to move to Snowflake data warehouse, right? So over here you can see that these are, I mean, few of the ways to, I mean, still the list is not complete. We have a lot of ways to move to the Snowflake data warehouse. Either we take it one by one, different structures, different options, and then move to there, or we have built in already, we have different systems. Oh, okay. We have different systems which we can use directly to connect to the source system, do the transformation, and then load it to the target system, right? Everyone comfortable? Are we all good till now? Any question? Anyone? Someone has any question? Whatever we have discussed right now.
What's the most best method to use?
Okay, so I'll mention those which are, thank you. So I'll see, looking at the market, so these two are very popular. They are over there in the market for very long. And out of that, I have seen people using Matillion is there. I mean, all these are very good, but this is something which I have used, which I have seen mostly in the market. It's S3 DBT Snowflake or S3 Spark. Okay. So these are the most important, most basic. And out of that, I have seen a lot of companies using Matillion, a lot of companies using Informatica. But I mean, see, the solution which you go right now. So, for example, if you're an organization who is interested to migrate to Snowflake Data Warehouse, it could be dependent on the budget as well. What is your budget, right? So the companies who do not have a very big budget or medium scale companies, they go with these options. The reason for this is because the S3 is very cheap, dbt is free, and you just have to pay for the Snowflake data, right? So this is the stack which is there with the small and medium sized companies. But as the size of your company grows, they will have a dedicated ETL tool for that. right? I'm not saying that the companies with large infrastructure will not use this stack, but still they prefer with an existing ETL tool, which is already there and it reduces their efforts, right? I have seen companies using Informatica, Matillion, but again, the big companies, they will always prefer an ETL tool. But if you, I mean, not always, but these are the different ways. But this is something which I have already seen a lot. Any questions? Anyone? Is everyone comfortable? Any questions? Please ask me any questions. Okay, else I'll think that I'm just the one who is speaking.
So,
Yeah,
Bipul,
hi,
like,
people.
are
I
we
just
going
had
to...
one question.
Yeah. Yes, go.
Yeah, please go
Yeah,
ahead, please.
Yes,
right.
go.
So I just want to understand how Snowflake is different from Fabric. Like both serve
Okay.
the purpose of a data warehouse, right? Data
That
warehouse
comparison.
solutions.
Yeah, that comparison we will understand. I mean, based on whatever, I mean, this thing what we have discussed so far. I mean, just going through from the basics. So any questions on this thing which we have discussed? Yeah, we will do the comparison with ADF. So Fabric also provides all these different features. It is just like the different thing, and ADF also provides all these features. Similarly, over here, you can see that I have also mentioned AWS Glue. AWS Glue is also a suite of different softwares or the different tools which helps you to extract the data, transform the data, and load the data. But again, these systems are not having these many features, right? So these are not very easily manageable, and these are not very easy to use. So over here, we have already seen that the Snowflake Data Warehouse, we choose Snowflake Data Warehouse because of these things. Okay. There could be another software which has similar capabilities, but all these things are not supported in all the different software systems we have around it. You could argue I can use AWS Glue to do the same thing. But again, it is not very easy to use. We have to have an instance, and then we have everything is different, right? It is not also very easy to integrate Glue with all the systems. We cannot do all the things which is there in Snowflake Data Warehouse. And in the Glue, again, if you want to do big data, for example, in the AWS Glue, I agree, we can do the extraction, you can do the transformation, you can store the data into the table. But again, if you want to do big data on top of it, if you want to use AIML, for example, if you want to do the big data, for example, then you will have to use the another services from AWS, right? You will have to use some other services. And if you want to do AIML, then you will have to use another services. You have AWS Bedrock, you have a different services. So not everything is in one place, right? So you have different softwares which have to be integrated. Then you have to use those services together. Whereas in this Snowflake data warehouse, you bring the data in place, you can manage it, you can maintain it. And over here in the AWS, if you look at AWS, for the user management, you will have to use something called as IAM. You have to use IAM for user management. You will have to use AWS Glue for ETL as a data warehousing. For the data warehousing, you will have to use Redshift. And then again, on top of that, if you want to do something, for example, if you want to do AIML on top of it, you will have to use AWS Bedrock. And then, for example, if you want to do something on the big data, then for big data, you will have to use some other services, right? So over here, you can see that even within AWS, you will have to use different services. And again, you can see that in the Microsoft Fabrics, you have different softwares which do a specific thing. And then you will have to take care of the user management, you will have to take care of the access management, and then you will have to take care of different services, take care of the different integration between different services. And over here, you can see that within the AWS, just to do the AIML, ATL, user management, and all these things, I have to use 4 different services. But Snowflake Data Warehouse is containing all these things into one system. You can do user management in one place. You can bring your data over here. You can do your analysis. You can load your data. You can use it as a data warehouse. You can do AML on top of it, and you can also do the big data analytics on top of your Snowflake data warehouse. Everything is in one, right? So, I mean, if you are aware of, I mean, I hope I answered your question, right? In the AWS, in the Azure fabrics as well, you have different places, you have different skills, or you have different tools to manage a specific type of thing, right? You cannot do everything in one place. You have to combine different small softwares. and each software does something, and then you have to integrate them. You have to do the user management in somewhere else, and this is how we use it in the different cloud technology. This is why the Snowflake Data Warehouse is a very, very good advantage. Okay? It offers everything in one place. If you want to, everything is managed and maintained, and then on top of this, the user management is here. If you want to do user management, it's here. If you want to use data warehousing, it's here. You can, if you want to manage your data, it is here. If you want to use AML on top of it, it is here. If you want to use anything, if you want to use Spark, or if you want to play around with the big data, it is also there. Okay. So everything is available in one place. Okay. Okay.
Yeah, so with respect to
Mhm.
then analytics, how superior is Snowflake when compared
Yeah.
to
All right.
other tools in the market?
Mhm. Okay. So over here, so if you look, if we just compare to the big data, right? If we just compare about the big data of Spark and of the Snowpark over here, so you might have already seen that people, if you look at this Snowpark, you can already see that the people are already migrating who use Spark. They are migrating all the code into Snowpark, right? If you search it, you will see that there are a lot. So over here, you will see that. So over here, you can see that if you are a company and you had an option to work with multiple tools who do specific things, or you need a place where you can do everything. Okay? So that is why one more thing. So in this Snowflake data warehouse, you can see that you just cannot move the data. So if you compare it to other databases or data warehouse, it is also giving the very good performance. And also on the pricing is also good. So for example, if you compare the Snowflake data warehouse, for example, Databricks or Redshift, people are saying that it is comparatively better in terms of pricing and also in terms of its performances as well. It is good not just with the performance, the pricing or is also very competitive for the Snowflake data warehouse. So that is why it is doing good in both the places. So it is not just doing good in the pricing, it is also doing good in terms of the performance as well. We have a lot of features in the Snowflake data warehouse which will help you to tune your data, to tune your performances, right? We have a lot of services which we will talk about. Even if your queries are running slower on Snowflake data warehouse, we have a lot of ways. We have performance tuning options. We have different options using which we can make our data store very optimally. And then we have something called as search optimization services. We have something called as the clustering of the data. So that is what will enhance in your experiences as well, right? And on top of that, we have different features. All the features which are already there in the market, that they are also provided in the Snowflake. Okay, so there is a question from the Softmail. Already learning or joining data engineering with Azure with KSR. Can you compare with that course? What value adds? Is it twice to learn parallel? See, if you have time, then you can do all these things parallelly, but it may make you confused. But what I will really suggest is that first of all you learn one thing and then you move on to this Snowflake database. Okay. So in terms of comparison, you can see that the Snowflake data warehouse is coming up in the market really, really better. If you look at the job market, you will see that because again, as a data engineer, we do not just have to analyze the data. We should know how to process different types of data. And then we should also know how to optimally query the data. And on top of that, we should also know how to do big data queries, how to do AI/ML. So that is why the Snowflake data warehouse is shining. As we have discussed, we can do everything in one place. Everything is under one roof. We can do everything. Big data, checked. Structured data, checked. On semi-structured data, checked. And then user management, checked. Everything is done in one system. So that is why also another reason why the Snowflake data warehouse is coming up very, very nicely. If we do not have to rely on different systems. Over here previously, you might have seen that we had different systems for doing a specific set of things. But right now, the Snowflake data warehouse is bringing all the features in one place. Similarly, just like our phones, right? Previously, we had cameras, and then we had music systems, and then we had a smartphone. We had a phone to call to someone. We had a calculator. Now we had all, and then we had a clock as well, right? We had an alarm clock. Would you go with these different skill sets? Although or you would get a smartphone which can do all these things, and not just equivalent, and it is also very, very nice economically. Instead of buying different systems, why not just buy a system which brings all the system in itself? You can do a lot of things over here. And again, the quality is also same. Whatever you can do with the clock, whatever you can do with the smartphone or your speakers, you can also do it in your smartphone as well. So that is why this Snowflake, and also at a competitive rate, right? So if you buy, oh, I understand some photographer will say that a dedicated camera is always better than iPhone 15 Pro Max's camera. But again, it is very, very comparable. You cannot see a very large difference between the cameras, which is worth rupees 1 lakh, or a smartphone, which is worth 1 lakh. So these things are there. So you can save money, you can have the similar performances. And again, in the iPhone, there are a lot of things. You have software to play around with your photos, whereas those things are not in your normal cameras, your digital camera. They do not have OIS, EIS, all these features, and then cleaning your photo, finding out which photo is better, and then giving you the best photo out there. These are additional features which we have in the smartphone these days, right? So I hope you found my answer. Okay. So over here, if we compare it to Azure, okay, because you are already learning Azure, or you are working on the Azure database, for example, already, then you can learn just one system, and this system is very, very adaptable, and there are a lot of companies which are already using it. So you will see a lot of requirements out there. In terms of requirements, this Snowflake Data Warehouse also makes a lot of good choice right now, because right now the market is hot, and we should take the advantage of that instead of learning the Snowflake Data Warehouse 1 year from now, or even 6 months from now, right? Because the Snowflake Data Warehouse is also done. So the value which you will get is that you will learn a new tool which is having a very good acceptance in the market. It is now stable as well, because now the software is available in the market for more than 10 years. If someone didn't know, the Snowflake Data Warehouse is available in the market for, I mean, they just celebrated last year, they celebrated their 10 years uh, foundational year. So they had 10th year anniversary. So this year they will complete it every year. So you can see that it is really old in the market, and they keep on coming with new features. They have Snowflake Data Warehouse, Cortex is there. So Cortex is there. So they're also bringing AML capabilities to the Snowflake. So if you learn this specific thing, if you learn this Snowflake Data Warehouse, you are going to go in the job market very confidently, and then you know a tool which is very, very accepted, and also again it is very easy to use. Okay, it's not very difficult to use. So we will spend somewhere around 18 to 20 sessions, and we will learn about every different features which we have in the Snowflake Data Warehouse, which will help us to shine in the job market. Not just a job market, we are also using for um, the different ways. For example, if you are looking for a switch, if you're looking for your career in the cloud services, we are all going to be ready for that. Okay. So I cannot directly compare the Azure with the Snowflake Data Warehouse, but the Snowflake Data Warehouse is having more market over here. Okay. So if you look at any data engineering job opening, you can see Snowflake Data Warehouse occurring in many, many different places. Or you see big data. If you see big data, then we have Snowpark. If you look at AIML, we have it in Snowflake Data Warehouse. So it covers all the different aspects. If you know Snowflake Data Warehouse end to end, you do not even have to learn any other tool. You do not even have to learn any specific skill set for that. One place, and all is done for you. Are we all good? Do we all agree?
Yes, people.
Yeah, MJ, you were about to say something.
Yeah, so just I wanted to understand like how many pipelines and
Mhm.
the different types of pipeline we are going to learn in this.
Okay. So these pipelines we will see. Apart from these, okay, we are not going to have the ETL systems. So these pipelines we will see. So these are the very, very famous pipelines which we have over here. And because over here you can see that we have different tools or different skill sets to move to the data to the Snowflake Data Warehouse, we also want to see how we can actually orchestrate them. Because over here you can see that one system is somewhere else, one system is somewhere else, and one system is somewhere else. So that is why we will also see how we can orchestrate the movement of the data, right? We just do not want to connect to one system to this one, and then have the system and then the system and then load it to Snowflake Data Warehouse. We also need to understand how we can actually move the data from one system to another system, how we can schedule this data, and how we can make sure that the data is also resilient. If something goes wrong over here, if something goes wrong over here, if something goes wrong over here, how we are going to handle it. Okay. So as a part of these data pipelines, we will see all these data pipelines, and we will also see how we can make our data resilient data pipelines. Okay. And then we will also see if some error occurs, if still we will be build rock solid resilient data pipelines. On top of that, we will see how we can schedule them, right? Because scheduling is also very important. How we will take care of the connection, right? Because we want the different systems to talk to each other for the connection or the communication, or I can mention the communication between different systems. Communication. So for this, we will see different orchestrators. We have the Apache. We have Apache. What was that? Apache Airflow. So we will see how we can use Apache Airflow to handle the communication between the systems and to schedule the systems and to make our data pipeline resilient. Because if something wrong happens, we know how to handle that. Okay. So all these things we will see, not just creating the pipelines. So here you can see that a list of very important pipelines which we have over here. On top of that, we will also see not just how to create a pipeline, but also to make sure that your data pipeline is resilient, it runs on the schedule, and it can communicate success or failure messages. So we don't want communication only on successful cases. We also need to have the messages from our ETL pipeline if it is failure. Okay. So we want to send the success or failure messages to the targets. If someone thinks that any of the pipeline is missed, if they have seen any specific pipelines in their organization, they can let us know. We can also include it. Okay, but these are the very major pipelines which are very important. And apart from that, of course we can include a lot of ETL tools, but these are the major pipelines. And then we have, for orchestrating them, we have something called as Apache Airflow, which will help us to build the resilient pipeline. Are we all good?
So we are
Yes.
going to cover the data break also. Huh?
Yeah, Databricks is also there. I mean, oh, I didn't mention it. Yeah, I mentioned it over here. So instead of Redshift, we can also have we can also mention Databricks, right? We can.
So what I understood, in the data break, you will write the PySpark code to connect the plugin.
Right. Right. You can do extract in that, you can do the transform in that, and then you can load it in Snowflake Data Warehouse. It's using Databricks.
Okay.
Okay.
And
So
Python you are going to cover
later on.
Sorry?
Python we will see later on. I guess after the Snowflake Data Warehouse and Snowpark. I mean, I do not know the exact pattern which the DataVision will go. They actually make their strategy based on the market and the demands of the users, of the customers. But right now, yeah, we have done MySQL. Right now we are doing Snowflake Data Warehouse. And then later on, we will either do Python, or, I mean, of course, we should go with Python and not with the Snowpark, because Snowpark requires Python. So we will go with Python, and then we will go with Snowpark. And over there, we can see how we can use the Snowpark services to transform the data, to manipulate the data which we have put into Snowpark.
So Snowpark, how many sessions are there?
Snowpark, there are somewhere around 10 sessions we have.
Okay. So is there any way we can join only the advanced topic like Snowpark and all that?
For that, you will have to check with the database. I am not the right person for that.
Okay.
You will have to check.
Can I get the details of this course content? Snowpark, what are the topics we are going to cover and all?
Yeah, I'll share it with you. Maybe I do not have it on my system, but I'll surely ask the DataVision team to share the detailed. I actually had it on my system, but I showed it for the MySQL and everything. But I will share it. Okay. Yeah, hi Ahmed. I got a question from you. How long will the course? So the course you are asking for from Snowflake, Snowpark, DBT, and Python, right? Okay, so that will be around 3.5 months. Okay, so yeah, Vikas, I thought you were about to ask. Okay, so are we all good? Are we good with today's session, Ahmed?
Sir, actually, I know a little bit about Snowflake. I want to know the similar answer to that previous question. Can we join the advanced sessions like?
Oh, that I actually, for that you will have to check with the KSR data. Sorry, I mean, I will. They actually do all the strategize and they plan everything. I have no direct control. You can check with them if that is a possibility.
Okay.
Thank you. Okay, Mahalia, are you good? Pritam, Tejendra, Mukesh, MJ, we have Satish, Rupali, Murli, we have so many people. Why no one is speaking? APO, Anil, we have Suresh, Meyapan, Gotri, Prasad. Any questions? Are we all good? I just want to hear your pauses. Can I have a yes
Yes,
or
sir,
no?
we are good.
Okay, you are good.
Yeah,
Thank you,
good from my
Pritam.
end.
Okay, MJ. Tejendra, are you good?
Yes,
Okay,
sir.
Meyapan, you are good. Rupali, are you good?
Yeah, we are
Did
good
you
to
get
go.
an insight? Yep, thank you so much.
Yes.
Did you get some insights?
Yeah, I did.
Okay,
Thank
thank you. So Murli, Satish, Suresh, Prasad Reddy, good, Gangotri, are we all
Good,
good?
sir. Good, sir.
Good.
Yeah,
Thank you
good.
so much. So we will continue from here. So tomorrow we will actually do a deep dive into the Snowflake data warehouse. So today we have got an idea of what we have and what we are going to discuss at a part of this course. But from tomorrow we will actually start with the Snowflake data warehouse. I guess tomorrow's session is also for the as an open course, which is available out there without any issues. So we will have a discussion from here. We will start from here and then I will just give you a glimpse of what we are going to discuss tomorrow, just for the curious people. So this is what we are going to start with. What is the Snowflake data warehouse architecture? Okay, so tomorrow we will understand what is the architecture of Snowflake data warehouse, and we will also see this. These are very important and very popular image which you might have seen for the Snowflake data warehouse. So over here we will understand what this means, how a query is actually sent to the Snowflake data warehouse, how it is optimized, how it is sent, how it is managed, how it is run, and then how the result is actually sent back to it. Okay. So tomorrow we will deep dive into the architecture and we will see how the query runs into Snowflake. Okay. Okay, then thank you so much for joining today's session. I hope you all enjoyed today's session and you are ready for tomorrow's session. Thank you so much. Have a good day. Bye-bye.